Every year at Convocation, UBC has the honor of bestowing honorary degrees upon individuals who, in the opinion of the university community, have fit the criteria of excellence and eminence in their chosen field. And we received scores of nominations, and I can tell you that the Tributes Committee really struggles in the selection of individuals to honor. It is the highest honor conferred by this institution. Victoria Kaspi exemplifies these characteristics, and I invite her now to step forward next to me to receive her honorary degree. Mr. Chancellor, Victoria Kaspi is a remarkable astrophysicist of global renown. Her professional life has been devoted to the study of pulsars, rapidly rotating, highly magnetized neutron stars left behind after a massive star explodes as a supernova. Using the most powerful radio and X-ray telescopes in the world, she observes these relatively tiny yet dense stellar remnants as they rotate, emitting bursts of radiation. Her current work includes the development of algorithms and the implementation of instrumentation for the Fast Radio Burst Project on the new Canadian Hydrogen Intensity Mapping Experiment, or CHIME, something that involves investigators and professors here at UBC in Penticton, British Columbia. Born in Austin, Texas, and raised in Montreal, Quebec, as a youth, her passions tended towards hockey rather than astronomy. But she was keen on mathematics and logic. Her interest in neutron stars was sparked at Princeton University, where she earned her PhD under the supervision of luminary astrophysicist Joe Taylor, who later went on to win the Nobel Prize in Physics. Today, she is a professor of physics at McGill University, director of the McGill Space Institute, a member of the McGill Pulsar Group, and has served as Associate Dean of Research and Graduate Education with McGill University's Faculty of Science. She was elected a Fellow of the Royal Society in 2010 and has received many prestigious awards and distinctions, including the Gerhard Herzberg Canada Gold Medal for Science and Engineering in 2016. The same year, she was appointed as a Companion of the Order of Canada. Her work was also recognized with the NSERC John C. Polanyi Award in 2010 and the Rutherford Memorial Medal in Physics in 2007. Mr. Chancellor, in recognition of her remarkable contributions to our understanding of the universe and her instrumental role in advancing the fields of astronomy and physics, I ask you to confer the degree of Doctor of Science honoris causa upon Victoria Michelle Kaspi.
By the authority of the Okanagan Senate of this university, I confer upon you, Victoria Kaspi, the title and degree Doctor of Science honoris causa. Congratulations.
We not only honor individuals with honorary doctorates to recognize their remarkable achievements and contributions to humanity, but also to give those individuals the opportunity to interact with their fellow newest graduates. That's you. Please join me in giving Dr. Kaspi a round of applause of congratulations as she approaches the podium to leave some words with you.
Mr. Chancellor, Mr. President, honored guests, fellow graduates, I am an observational astrophysicist. I use large telescopes, some ground-based, like the 305-meter Arecibo Observatory in Puerto Rico. I also use space-based telescopes like NASA's Chandra X-ray Observatory, which produces unparalleled X-ray images of the sky. That may sound exotic and unusual to you, but it describes my daily life for the past 30 years, so is pretty normal to me. But when I graduated with my bachelor's degree from university, as many of you are today, I had never taken a single astronomy class, had never looked through a telescope, and really had no idea that astrophysicist was even a job possibility. And yet, here I am. And I love this job that I never imagined I would have. I can't believe they pay me to do it, to solve puzzles and interact with bright, motivated students like you. So, how does one end up from point A, a degree from university, to point B, your dream career, when number one, you may not know yet what your dream is, and two, you may not even be aware of the existence of the type of job that will one day make your dream come true. Some of you may already know where you're going and how you plan to get there. I admire you. But for the people who don't, how do you find where you're going? How do you find your point B? To find your point B, here is my advice. Number one, give thought to what you find interesting. Look for your passion. It doesn't matter what it is. Biomolecules, climate, dark matter, crack propagation. This is a vast and complex world, and there is room for all sorts of people doing all sorts of things. I recently met a woman whose passion was the history of textiles. A material scientist, she now works for museums in New York maintaining ancient cloths from tapestries, clothing, and bedding. I didn't know that was a job. On an airplane, I once met a man whose interest is adhesives. Originally a chemist, he's now president of a company that makes the tiny stickers stuck on fruit in the grocery stores. He spoke passionately to me about peel. The world needs people who care about what they do, whatever it is. Caring with passion means you will do superb work and invent or discover better ways of doing things. You will improve some aspect of the world, and as a bonus, you will enjoy it. The world has huge problems, so many challenges. There is so much work to be done. Which brings me to point two. You cannot do everything. Don't try. But you can do several things. If you have multiple passions, you can manage a few. For me, my passions are my work and my family. I've had to give up things to do my passions well. So be prepared to make some sacrifices. Make no mistake, accomplishment demands dedication. Dedication demands time. And there are only finite amounts of time, so time demands sacrifice. I don't worry about sacrifice. With luck, later in life, I can do some of the things I put off. Which brings me to number 3 in my list of what's needed to find your point B, luck. Luck is very helpful. And that may worry you because no one can guarantee you luck. But the old adage says luck favors the well-prepared mind. Be well prepared to seize on opportunities when they arise, and they will. And yes, some opportunities may lead you out of your comfort zone. But graduates, no pain, no gain. There's not much truly worth doing that doesn't require some sweat. I live a good fraction of my life outside my comfort zone. And in fact, today I'd say my comfort zone is outside my comfort zone. Currently, I'm principal investigator on the Canadian Hydrogen Intensity Mapping Experiment Fast Radio Burst Project. It's a project to understand a new and surprising astrophysical phenomenon, fast radio bursts. Fast radio bursts consist of short, few millisecond bursts of radio waves that are constantly and randomly hitting the Earth, each from a different, unpredictable location on the sky. They are arriving from far, far outside our Milky Way galaxy, and we have no idea what is producing them. It's an interesting puzzle. How can you study a phenomenon when you don't know when or from where it's going to appear? And then it disappears. You need a sensitive telescope that can look everywhere all the time, which sounds crazy. But that's exactly what CHIME does. How's that possible? It's a revolutionary new radio telescope design consisting of 1,000 antennas suspended over enormous reflectors. The antennas are fed into a powerful supercomputer. And that allows us, the supercomputer allows us to combine antenna signals to see vast areas of the sky all the time. I mentioned CHIME for two reasons. First, UBC Okanagan graduates, it's in your backyard. We, meaning researchers at McGill, University of Toronto, and University of British Columbia, have built this world-class, revolutionary, all-seeing telescope in the outskirts of Penticton, on the grounds of the Dominion Radio Astrophysical Observatory. Go visit it. I promise you it is something to see. But second, being PI of this project took me far out of my comfort zone. It's a complex project with no blueprint. But I really want to know what fast radio bursts are. And struggling with the project has taught me huge amounts about astrophysics, programming, supercomputing, and above all, the power of teamwork. I work with an awesome crew of scientists, students, professionals without whom it would not be getting done. Finally, my fourth piece of advice for finding your point B. About 20 years ago, I was professor at MIT, which at the time was my dream job. It was great. But I missed my family back in Canada. McGill called with a job offer, and I accepted. I've never looked back. Canada is a fantastic place to do great research. We don't give ourselves enough credit. Plus, my kids got to know their grandparents. That makes me happy. My elder daughter is 15, and recently she started saying things to me like, "Mom, can you please pick me up from my friend's house, but when you get there, wait in the car?" I suspect that the parents here know what I'm talking about. Fellow graduates, remember going forward, and especially on an important day like today, all the time your parents or whoever cared for you picked you up, yet waited in the car, supported you, yet gave you independence. When this commencement is over, give them a big hug and cherish their love and devotion throughout your adult lives. And so graduates of class of 2018, there you have it, my recipe for finding your point B. Do what you love and do it well. Don't try to do everything. You will have to make some sacrifices, but they may be temporary. Seize opportunities when they arise, and they will. Be prepared to exit your comfort zone, because that will enable you to achieve great things. And last but not least, don't forget who helped you get where you are today and where you will be at your point B, whatever it turns out to be. Thank you for your attention.